Hi, so I just wanted to talk a little about the biggest discovery that was made yesterday. So this is just a layman's perspective, so I hope this goes well. So the Standard Model is basically the most complete theory in all of physics. It explains three of the most fundamental forces of nature. The electromagnetic force, this is the force between nucleus and electrons. The strong force, this is the force between neutrons and protons inside the nucleus. And thirdly, the weak force, this is the force between quarks inside the protons. So as we see, we just go from a bigger scale to a smaller scale, and at each level there's a different force acting, or in many ways the same force acting in a different way, or different phases of the same force. Now, in the Standard Model, all particles can be categorized into three basic categories. Number one is the Hadrons. These are the heavier ones, like protons. Number two is the Leptons. These are the lighter ones, like electrons. And number three are the Bosons. These are the carrier particles. Now, different bosons have different functions. The boson for electromagnetism is Photon. The one for the strong force is gluon, and the ones for the weak force are W and Z Bosons. Their behavior was first modeled by a Dhaka University professor named Satyendranath Bose with a little help from Einstein, and this became famous as the Bose-Einstein statistics. Now, as we can see, all the bosons that I described before are description of forces, which is a vector quantity. By that I mean something that can be quantified and has a direction. But how do we explain scalar quantities like mass with the Standard Model? That was a puzzle until yesterday. Peter Higgs in the 1960s proposed a Higgs field, which is filled with scalar Higgs particles. When heavy particles like protons or electrons float through the Higgs field, they interact more with the Higgs field and they gain mass. This is like swimming in water with jeans on. The jeans absorbs more water and it feels much more heavier. While photons travel through the Higgs field without interacting and they don't feel any mass. So that is like wearing a diving suit in the water that makes it feel like there is no water. So that's basically what the Higgs field is. It is the field through which when particles move, if they interact, they gain mass. If they don't interact, they don't have mass. Now, what does this mean for us? Scientists confirm that a new particle exists in the mass range of 125 gigavolts or something, giga-electron volts, with 5 sigma precision. That is, the probability of it being wrong is 1 in a million. So the particle definitely exists. A new particle definitely exists. Whether it is the Standard Model Higgs, we don't know yet. We don't know yet. But if they test it and it turns out to be the Standard Model Higgs, it's great news. But if it turns out to be a different kind of Higgs particle, then that might tell us that there are more scalars to look for. So that means we'd need a whole new physics for describing the scalar fundamental particles. That is very exciting for new physicists. If you're in high school right now, and if you're interested in physics, this is like happy time for you, because now you have something to look for. Now you have a direction to look into. And wherever you look, this is a new frontier, like Columbus landing on America. Wherever you look, you will find new things. That is why it is so important. And if I want to be really science fiction-like, maybe one day we'll learn how to manipulate this Higgs field and maybe swim through it at the speed of light, wearing a diving suit of some sort. Just saying, nothing's impossible.